The quest to find extraterrestrial life has been one of the most enduring and ambitious scientific endeavors in modern history. The search for signs of life beyond Earth, once considered a speculative dream, has gradually evolved into a serious scientific pursuit. The idea that intelligent life could exist somewhere in the vast expanse of the universe has captured the imaginations of millions. The possibility that humans might one day make contact with beings from other worlds remains one of the most profound questions in science. But despite the countless efforts, the question remains: are we alone in the universe? One of the most prominent projects in this ongoing search is the SETI Search for Extraterrestrial Intelligence initiative. For decades, SETI has employed powerful telescopes, advanced technologies, and the most sophisticated algorithms to scan the cosmos for signals that might indicate the presence of alien civilizations. The goal has always been to detect artificial signals, radio waves, or other electromagnetic emissions that might be produced by intelligent beings from distant planets. It's a task of immense complexity, given the vastness of the universe, but SETI researchers have never been deterred. Among the various methods used to search for extraterrestrial life, one of the most innovative and groundbreaking initiatives has been the SETI at Home project. This project, a crowdsourced scientific effort, invited millions of volunteers from around the globe to participate in one of the most extraordinary collective scientific endeavors in history. By harnessing the power of volunteers' home computers, SETI at Home transformed the search for alien life into a global community effort. It became not just a scientific pursuit, but a social phenomenon that allowed people from all walks of life to contribute to one of humanity's most fundamental questions. Launched in 1999 by researchers at UC Berkeley, SETI at Home set out with the goal of processing the enormous amount of radio data collected by telescopes like the Arecibo Observatory in Puerto Rico. The data, which contained signals from outer space, was simply too vast for traditional supercomputers to process efficiently. This is where volunteers' home computers came into play. SETI at Home developed software that allowed individuals to install it on their personal computers, which would then run in the background, processing chunks of data while the users went about their day-to-day activities. The project became a decentralized network of computing power, essentially turning the internet into a global supercomputer capable of analyzing radio waves from the depths of space. Over the next 2 decades, millions of people joined the effort. By 2020, SETI at Home had accumulated over 12 billion potential signals, with volunteers contributing their computing power to analyze vast swathes of data from radio telescopes. The collaboration between science and the public was an unprecedented success in terms of sheer numbers and the power it generated for the project. But as with any scientific undertaking, not all of the signals captured were significant. In fact, most of the signals were eventually discarded, as they were deemed to be either noise or the result of natural phenomena. However, after 21 years of analysis, the SETI at Home team narrowed the data down to 100 signals of interest. These signals were unique, exhibiting characteristics that made them worthy of further study. While it's too early to say whether any of these signals indicate the presence of extraterrestrial intelligence, the project marked a major milestone in the search for alien life. The final set of 100 signals represents the culmination of over 2 decades of effort and serves as a testament to the power of citizen science and global collaboration. The results from SETI at Home, which were published in 2 papers in the Astronomical Journal, offered something even more profound than the detection of a single alien signal. According to David Anderson, a computer scientist and co-founder of the project, the true achievement of SETI at Home lies in the new sensitivity level that the project established. In essence, the project set a new standard for what was detectable, meaning that if a signal from extraterrestrial intelligence were strong enough to be identified, SETI at Home's methods would have found it. While this might sound like a modest conclusion, it's actually a monumental achievement in itself. It means that even if no alien signals were detected, the project laid the groundwork for future searches. It demonstrated the technological capabilities required to detect signals of a certain strength, and in doing so, it helped redefine the search for extraterrestrial intelligence. The scope of SETI at Home's success extends beyond the scientific community. As one of the first large-scale examples of crowdsourced science, it showed how the collective power of ordinary individuals could contribute to cutting-edge research. The project not only advanced scientific knowledge, but also fostered a global community of people who were actively engaged in the search for life beyond Earth. The sense of participation was empowering for many volunteers. Each person who lent their computer's processing power became part of something much bigger than themselves, contributing to a shared goal of unlocking one of the most profound mysteries of the universe. The success of SETI at Home wasn't just about the results, but also about the process. The project pushed the boundaries of what was thought possible in terms of distributed computing. By allowing millions of individuals to donate their computing power, SETI at Home created a network that was far more powerful than any single supercomputer could ever be. Volunteers from all over the world contributed, from individuals in small towns to tech-savvy professionals. The project demonstrated the power of a global network of computers working in tandem to solve a complex scientific problem. As ambitious as it was, SETI at Home did face challenges along the way. For one, the sheer volume of data it had to process was staggering. Radio telescopes like Arecibo generated massive amounts of data, much of which had to be sifted through in order to find meaningful signals. The complexity of the task required not only massive computational power, but also sophisticated algorithms to detect signals of interest from the vast background noise. The volunteers involved in the project were not just passive participants. They were integral to the process of identifying and analyzing these signals. Through their efforts, they helped make sense of the raw data collected from space. The project also faced difficulties in terms of funding and support. While it initially garnered significant attention and participation, the rise of newer technologies and the eventual shutdown of the Arecibo Observatory in 2020 brought challenges to SETI at Home. The end of the Arecibo Observatory, once one of the most important instruments in radio astronomy, meant that there were fewer sources of data for the project. Despite these challenges, SETI at Home continued to function through the support of its global community of volunteers, who remained committed to the search for alien life. One of the key innovations of SETI at Home was its approach to data processing. Rather than relying on a centralized server, the project used volunteer computing to distribute the workload across a vast number of individual machines. This approach allowed the project to scale up quickly and process far more data than would have been possible with traditional computing methods. It also provided a unique opportunity for people to contribute to scientific research in a meaningful way, without needing advanced scientific training or expertise. All that was required was a home computer and an internet connection. By the time the project reached its final stages, it had harnessed the power of millions of people, contributing to an unprecedented effort to analyze the signals of the cosmos. Although the SETI at Home project officially concluded in 2020, its legacy lives on in the scientific community. The project helped lay the foundation for future endeavors in the search for extraterrestrial life, providing valuable insights into the methods and technologies that can be used to analyze cosmic signals. The data and findings from SETI at Home will continue to inform future research in the field of astrobiology, guiding new efforts to search for intelligent life beyond Earth. As we look to the future, the question of whether we are truly alone in the universe remains as tantalizing as ever. While SETI at Home's findings may not have yielded definitive proof of extraterrestrial life, the project demonstrated that the search for alien signals is not only possible, but is advancing at a rapid pace. The world's collective curiosity about what lies beyond our planet is stronger than ever, and as technology continues to evolve, so too will our ability to detect and analyze signals from distant stars and planets. In the end, the search for extraterrestrial life is not just about finding alien civilizations. It's about expanding our understanding of the universe and our place within it. Through projects like SETI at Home, humanity has taken significant strides toward answering one of the most profound questions of all: are we alone? And while the answer may not be immediately forthcoming, the journey of discovery continues, powered by the collective effort of scientists and ordinary people alike, all united in the quest to explore the unknown.